Welcome to Brain Vision.
We need to find the moment applied at this point A due to an input moment of -500 pounds-inches at the point F. And we also need to find the reactions at the point B, the point D, and the point E. And this problem is in 3 dimensions, so we're going to be using vector components to help solve the problem. So we're going to start by looking at this free body diagram on the left, from point C to point F. And from that free body diagram, we can say that the sum of moments about its x-axis is equal to 0, which we can write as moment about the point C times the cosine of 30 minus 500 is equal to 0. And we can solve for the moment m of c to get a value of 577.35 pounds-inches. So we're now going to look at the free body diagram on the right, and I've already labeled the moment that we've calculated for. So we're now going to say that the sum of moments about the point C is equal to 0. And we can write that as the moment about A as an I component plus the moment about C plus -5i times by prime of j. And we call this y prime because if we look at the diagram, we see that this y component here is on its own axis, on its own y-axis, compared to this y component. So we label it as prime, so we know that it's on its own axis. Then we'll have plus b of zk is equal to 0. And we can plug in m of c. And we'll be left with just vector components. So after plugging in, we'll get m of ai minus 577.35i. And then this expression, so this expression here, I'll circle it, this expression here, we can actually rewrite it as plus -5 times b of y prime k plus 5 times b of zj, and set that equal to 0. So we see that we're just left with vector components. So we can now solve for this unknown m of a. So we take just the vector components of I. So we'll have m of a minus 577.35 is equal to 0. And solving for m of a, we'll get a moment that's equal to 577.35 pounds-inches. And we're now going to solve for the reactions, so part B. And from this same equation, we're also going to take the k components and the j components and set them each to equal to 0. So next we're going to have 5 times b of z is equal to 0. And we're also going to have -5 times b of y is equal to 0. And solving these for their components, we'll find that b of z is equal to 0 and b of y is also equal to 0. So we can conclude that the reaction at the point B is just going to be equal to 0. And next we're going to apply we're going to say that the sum of forces is equal to 0 using the same free body diagram. So whatever forces is at point B has to be equal to the negative forces of point C. So that means that B, the forces at B plus the forces at C is going to be equal to 0. And we already know that B is 0. So that means that forces at point C is also going to be equal to 0. So we're going to go back to our free body diagrams. And we're going to go back to the free body diagram on the left and take the sum of moments about the point D. So the sum of moments about the point D is equal to 0. And we can write that as m of C times the cosine of 30i plus the sine of 30j minus 500i plus 6i times e of xi plus e of yj plus e of zk is equal to 0. And this MFC, so we know what MFC is, so we can plug in the value 577.35 into this term, and we'll be left with just vector components. So after plugging it in and rewriting the equation, we'll end up with 500i plus 288.68j minus 500i plus 6 times e of yk minus 6 times e of zj is equal to 0. So we notice that we're just left with vector components. So I'm going to start with the j components and say that 288.68 minus 6 times e of z is equal to 0. And solving for e of z, we get a value e of z that is equal to 48.1 pounds. And we'll now take the k components and set them equal to 0. So we'll have 6 times e of y is equal to 0. And solving for e of y, we'll find that it's equal to 0. So we can now apply the force principle that the sum of forces is going to be equal to 0, which we can write as the force C plus force Z plus force E is equal to 0. And we know that C is 0, so we can write 0 for that, plus the components of D, which we'll write as d of y, j, plus d of xk, plus e of xi, plus 48.1 K is equal to 0. And we're again left with an equation that only consists of vector components. So we find that e of x is equal to 0, since that's the only I component, so we can set e of x equal to 0. And for the j components, we see we only have one j component, so we can also say that d of y is equal to 0. So to get the z component of d, we can say that 48.1 pounds, so 48.1 plus d of z is equal to 0. And solving for d of z, we'll get a value equal to negative 48.1 pounds. So now for our final answers, we say that the reaction at point B is equal to 0. The reaction at point D is equal to negative 48.1 pounds K. And the reaction at point E is equal to 48.1 pounds K.